Hey folks, how you doing? We're on page 90 and we're looking at number 10. Alright, so in this problem they tell us we got a bag that's got 4 marbles, it's got a 2, 4, a 5, and an 8 in it, and a B that's got 5 marbles and it's labeled, and then C it's got 7 marbles, and they want to know the probability of finding exactly 2 of the selected balls being the same. So let's take the information and kind of set it up so it's a little bit easier to see than when it's on the paper. So A has got 2, 4, 5, and 8. That's 4 of them. B has got 1, 3, 6, 8, and 8, and that's 5 of them. And C has got 2, 7, 8, 8, 8, 9, and that's going to make a total of 7 balls. All right. So if we're going to find the probability exactly of 2, we have to take a look and find out which ones are repeated. Well, you notice that A and C both have 2s, and then A, B, and C both have 8s. And there's no other numbers that get repeated, so we're talking about 2s and 8s. So the first thing is let's figure out how we can find 2s. Well, the only way we can do it is if A pulls a 2, B doesn't pull a 2, and C does pull a 2. Well, the probability of B not pulling a 2 is a 1 because it doesn't have any 2s. Now, what other possibilities can we have? Well, we have an 8. A could pull an 8, and B could pull an 8, and C could not pull an 8. So then we fill in those probabilities. And then we look at whether another way that we could get 8s. Well, A could not have an 8, B have an 8, and C have an 8. So we pull the probabilities just by counting the balls and dividing by the total number of balls. So, for example, in A, there are 3 that don't have an 8. All right, so then we take those. Now we look for any other possible ways that we can get 8s to match. Well, if A has an 8 and B does not have an 8 and C does, well, then I'll still have 2 8s. So it's 1/4 times 3/5 times 4/7. All right. And now all we've got to do is multiply and add, and we'll end up with our solution, which is going to be 47 over 140, or 0.336 to 3 significant figures. All right, so now let's take a look at part 2. In part 2, they're given that exactly 2 of the selected balls have the same number. Find the probability that they're both numbered 2. So we're finding the probability that 2 of the 3 selected balls are a 2, given that 2 of the balls are exactly the same. 2 of the 3 balls. All right, so what we're basically going to do is we need to find the probability of both of these things happening, 2 of the 3 being selected and 2 being the same. And then we've got to divide it by the given, which is 2 of the 3 selected being the same. Well, if you recall previously, we have already taken a look at all the different ways to pull out balls where 2 of them are the same. So only one of these scenarios involves 2s, and so we know the probability of that. We know the probability of 2 balls being selected and being the same and being 2. It's 1 over 28. And we also know the probability of 2 of the 3 balls being selected being the same, because that's what we figured out in part 2. That's 47 over 140. So if I divide, I get 5 over 47, or 0.106 to 3 significant figures. Now in part 3, they're saying that X is exactly 2 of the selected balls have the same number, and Y is the ball selected from bag A is number 2. So let's kind of take that information and jot it down, get it in front of us. X is exactly 2 of the balls being the same. All right, and while you're writing that, you should be thinking, I've already done some stuff with this, so I may be able to reuse some information. And then Y is exactly the pulling of a bag from pulling the bag from A and getting the number 2. So if I pull a ball from A, what's the probability that it's going to be a 2? All right. Now, this thing at the bottom of the question, you'll notice how it says, show your working, determine that the events X and Y are independent or not. So, independent events, let's take a minute and let's talk about what independent events are. We've dealt with it a little bit, but not a ton. So let's see what we can jar your memory about independent events. Independent events do not affect each other. And we'll do an example with a die. All right, so, but the first thing you remember is that independent events do not affect each other. For example, if we roll a die, and I want the probability of giving an even and it also being below 3. Well, if I take a look at the evens, I've got 2, 4, and 6, and below 3s, I've got 1 and 2. All right, now, if I find the probability of finding an even, that's going to be 1/2. And if I find the probability of below 3, that's going to be 1/3. If I multiply them together, I got 1/6. Now, if I just try to do this intuitively, you'll notice that there's only one number that meets both criteria, the number 2. The 2 is even and below 3. And so it is the only one out of the 6 that really does meet the criteria. The probability is going to be 1/6. Now, the thing is, if you multiply the probabilities of them separately and you get the same as what it really is, then we know that the events must have been independent. So let's go back over to our problem. We've got to see if we can multiply these two probabilities separately. So the probability of X is going to be 47 over 1/40th. We've already figured that out. If you want to take a minute and pause this video and read part 2 and see if you can understand why they are the same. So now what we've got to do is figure out what the probability of Y is. Probability of Y, well, there's only 1, 2 in bag A, so that's going to be 1 out of 4 balls, it's 1/4. So if these are independent, then if I take the probability of X and multiply it times the probability of Y, I should get the same probability of both of them happening. So that's only if they're independent. So first we'll try multiplying them. Well, 1 times 47 is 47, and 4 times 140 is going to be 560. All right, now let's see if that really is the probability of both of these things happening. Well, there's a couple different ways to go about it. Number one, if you look in part 2 where we did the conditional probability, in that part it says at the very top, we're looking at the probability of finding 2 of 3 selected are a 2, given that 2 of the 3 are the same. And then to figure it out, we had to find out the probability of both of those things happening. And we decided that was 1 over 28. Well, that is the probability of both of these things happening. It's 1 over 28. If you take a look, both of those events describe X and Y. And so putting them together is 1 over 28. Now the thing is, 47 over 560 does not equal 1 over 28. So the probability that we get by multiplying them two separately doesn't equal the true probability of these two things happening together. So they cannot be independent. All right, it's a little bit of a difficult concept. I hope that helped a little bit. Thanks for watching.